So far we have seen the various scheduling algorithms, right? Now let's see the various states which are possible for a process, okay? It is also called as process state diagram, okay? Which means what are all the possible states a process can be in our computer, okay? That is what we mean by states of a process, okay? Fine. Now let's start. Initially, a process will be in new state, right? What does it mean? For a program, a process will be created. That's what we mean by a process is in new state, right? Now, once it is done, this will be moved to the RAM, okay? Initially, a process will always be in ready state for some time at least, okay? So, which means a process from hard disk cannot directly go to a running state, okay? It needs to come to the RAM first and then it needs to execute, okay? Also, a process cannot go to an IO state directly. Why? See, what is meant by IO state? IO state means our program needs to read some data from IO devices, okay? Read or write from IO devices. That's what we mean by IO, right? Now, how will we know that our program needs to read or write some data from the IO devices? Only after executing the program, right? Which means our CPU needs to understand the program, right? See, for every program we don't need to do IO. Only for some programs we need to do IO, right? Now, when the program is given to the CPU, which means when the CPU needs to execute that program only at least for some time initially, okay? Initially always the program will be executed, and only after executing the program the CPU will decide that okay, this program needs some IO, so it has to be moved to IO state, okay? So every program will first be going to ready state. From new state, a program should always go to ready state. There is no other way, okay? So a process in new state will move to ready state. It cannot go directly to running state, fine, as well as it cannot go directly to IO state. Now from new state to ready, it has reached ready state. Let us assume it has reached ready state, right? Now from ready state, what are all the various possibilities, okay? Let's assume the process is in RAM, okay? It is in ready state. Now from the RAM, can the process directly go to IO state directly, straight away? It is never possible, okay? The process has to go from ready state to running state, okay? The process has to go from ready state to running state, okay? Why it cannot go directly from ready state to IO state? See, generally, when will a process go, before going to IO state, this process has to be decided, right? This process needs, whether this process needs IO or not, which is being decided by our CPU, okay? So, if a process from ready state can only go to running state, okay? So ready state, it can go to running state. Now how will it go to running state? Based on a scheduling algorithm, right? Based on our scheduling algorithm is which decides among the various processes which are in the ready state. Our scheduling algorithm decides one of the processes and then it will schedule it to the CPU, right? So a process can go from ready state to running state. That is always possible. Now let's see what is meant by suspend ready. Okay, let's see a bit later. Okay, suspend ready. Fine. See, a process can go from ready state to running state, that's fine. Now, why one thing I wanted to clear here is why a process cannot go from ready state to IO state. I think I have already told it, but still let me tell you one more time. See, our process is initially in RAM, okay? Now, you might ask a question, can this process directly go to IO state? Which means, can this process directly read or write some data from IO devices or not? The answer is no. Why? Because whether this program needs to read the data, write the data or not is being decided by our CPU. Okay, it is being decided by the program itself. That really depends on the logic which is written inside the program. That is fine. But this program has to be understood by the CPU, right? Our CPU needs to understand the program. Only after this process will be given to IO state, right? So a process can go to IO state only from running state, right? The process will move from ready state to running state, execution, fine. After execution for some time, the process will either go back to ready state. Why? In case of preemption, right? See, a process can be preempted because of priority, because a high priority process might come into the RAM, and so that process might have to be scheduled. So what we will do is we will actually preempt the low priority process and then again we will place it in the ready state, right? We have seen it. Now also because of time quantum, only in case of round robin, right? In case if you are using a round robin scheduling algorithm, after executing a process for a one time quantum, we will move the process to a ready state and then we will take the next process, right? That is what is given here. Now from running state, in case if a process has completed its execution, okay, in case if a process has completed its execution, the process will go to terminated state, okay. Once a process reaches terminated state, this process will be completely removed from the RAM, which we have seen it, okay. Fine. Now let's see this. When a process is being executed by the CPU, let us assume there is a program, okay. Process is nothing but program, right? It will have a lot of logic. Now when reading some logic, our CPU will understand that yes, this program needs some IO event, which means this program, in order to execute the program further, I need to have some data, and that data is present in one of the IO devices, like either hard disk or printer or anything, okay. So that is being decided by your CPU, and so it will be given in the process will go to IO state, okay. See, there are a lot of concepts to discuss here, control signals, timing signals and all this, which means our CPU will give control signals to IO devices. See, one question I wanted to ask is, I want to briefly discuss this point, okay. How will our IO devices work in our computer? See, whether it be a printer or it be a mouse, okay, or it be a keyboard or any IO device you take, these devices work in our computer because they are given some signal called as control signals by our CPU, okay. It is our CPU who is the captain of the ship, who is giving some signal in order to make these devices, okay. Every time our CPU needs to generate some signal, okay. Whenever you press you type a letter in the keyboard, that letter you type is being accepted by your keyboard only because of one thing, and that is because of the CPU. It is actually generating a signal, which we also say that as control signal, okay. As this is not very important for operating systems, actually this is a concept which is discussed in computer organization and architecture, okay. Let's see in a separate course, okay. As of now, let's not speak about this. I just want to tell that a process cannot go to IO state directly from ready state. It can go only from running state because it is our CPU who needs to decide whether our process should undergo IO or not, okay. Fine. From running state, a process, once IO request comes, it goes to IO state or block state. We know why IO state is also called as block state. We have seen a lot of times. Fine. Once the IO is complete, which means let us assume our program, in order to execute our program, some data has to be read from IO devices, right? Read or written. Now let us assume that read or write is completed. Now what we will do is we will again place the process in the ready state. Why are we not giving directly to the running state? Because our CPU might be busy executing some other program, right? See, why are we using, this is actually a multi-programming operating system. Why are we using multi-programming operating system? In case if a process is undergoing IO, some process will be executed by the CPU by taking it from the ready queue, right? From the ready state, right? That is the main advantage of multi-programming OS or batch OS, right? So there might be some program which might be executed by the CPU, and whether this program which has completed its IO should execute first, or the program which the CPU is currently running should execute first, is being decided again by our scheduling algorithm, which we know, right? Now in order to apply scheduling algorithm, the process has to be in ready state. Why? Because we have seen it, right? Our scheduling algorithm will choose one of the processes in the ready state. So once IO is done, we are placing the process in the ready state, okay? Because our scheduling algorithm will choose one among these processes as well as the process which is running. It will choose one among these processes on which one to execute next, okay? That is what the scheduling algorithm does. Now what is meant by dispatch, we will see it a bit later, okay? Fine. So this you are understood, right? Once IO is done, we will always place the process in the ready state and it cannot go directly to running state. That's the important point. Fine.